before we get into speed and velocity, we need to define two quantities, scalar quantities and vector quantities. So scalar quantities are any quantities that are measured that do not have direction. So total numbers, X number, 100 M&Ms, 10 liters, volume does not have a direction associated. So this is no direction. Mass does not have direction. Other quantities that would have density does not have direction. Length. So all those do not have direction. So those are all scalar quantities. Vector quantities has both magnitude and direction. So magnitude is really another fancy way of saying size. So don't get confused when you see a problem that says magnitude. It's just how big, what's the number, and they're not concerned about a direction. So things that have magnitude and direction would be things like displacement, which is a straight line distance between 2 points with direction. Other things we're going to see is velocity, acceleration, weight, because weight is always acted towards the, downwards towards the center of the earth. And another one, forces. Forces are all directional. Okay, over here, back on scalar, we have velocity, but we're going to put speed over here because speed does not have direction, and we'll talk about that. Length is really a distance, and we're going to talk about that on the next slide. Oops, distance. So length and distance. So the scalar, again, all quantities that do not have a direction associated. Vector quantities all have a directional component to them. So both size and direction. Scalar is just size. Okay, so let's talk about distance and displacement for a moment. So let's say that we're starting up here in Pittsburgh, and we wanted to go down here, I don't know, right down here, just north of California near Charleroi. Well, to get there, we would have to travel a distance of all these windy roads and then head back this way. So we would travel all of this distance, so somewhere around, I don't know, maybe this is 50 kilometers and then maybe another 30 kilometers this way. So our total distance, let's say this is 50 kilometers, and let's say that this is 30 kilometers. So our total distance that we would have traveled is 80 kilometers. So 50 plus 30 is equal to the 80 kilometers. This is the distance that we traveled. Okay, but our displacement is really from here to there, and it's a straight line. I'm going to put that in dotted. This is really our displacement right here. So this is almost, if this was like a nice clean 3, 4, 5 triangle, this might be really only 40 kilometers. So, but it's 40 kilometers in it's almost due south direction. So displacement, straight line distance between the 2 points, is 40 kilometers. So our distance that we traveled was 80. Our displacement, straight line distance from start to end, is 40 kilometers. So you can see that they're not the same. Distance and displacement are not the same. They are both a measurement of length, but one has as direction. And then we were calling this south. So that's important when we start talking about speed. So, okay, so our speed and velocity are the same. So going back to that example, we had a distance of 80 kilometers, but our displacement was equal to 40 kilometers. And I'll put an S there for south. So speed is equal to distance divided by time. So how long did it take you to get there? Velocity is going to equal displacement, all divided by time. So you can see they're very closely related. They're both a distance type thing over time. But let's see, if it took, I don't know, let's say 2 hours, let's say time is equal to 2 hours, then the speed here is equal to distance of 80 kilometers over 2 hours, giving us 40 kilometers per hour. That was our average speed. But the velocity is equal to the displacement, which is 40 kilometers over the same amount of time of 2 hours. So our average velocity was 20 kilometers per hour in the southerly direction. So you can see those two values are definitely different. This is how fast you were actually riding in the car, but this is really how fast you were going in the southerly direction on average. Okay, so there's the difference between speed and velocity. One quick question is, can you have a speed and velocity that are different where one of them is actually zero? And you can see that, let's say you started at this point and then you drove and drove and drove and drove and went all the way back to your starting point. Well, you traveled this whole distance, but your displacement is zero. You started and ended at the same point. So your displacement is zero, so you can have a zero velocity over that time interval, but zero speed. Okay, so let's take a look when we're looking at straight lines. So again, if we think about this in straight line motion, if we start, say, here, so this is our starting point at 10 centimeters. Hopefully you can read this well. So we're going to start at 10 centimeters, and let's say we're going to go 10 centimeters to the east. And I'm taking that as to the right. And then I'm going to go 15 centimeters west, so therefore that would be left. And then finally I'm going to go 20 centimeters east again. So you can think about you're sort of pacing back and forth. So I want to know, what is the displacement and distance that say I or an ant or a bug would travel. So if we start off, we're going to start here and we're going to go 10 centimeters east. So we're going over 10 centimeters. That puts us at the 20 centimeter mark. So this is 10 centimeters. I'm then going to go from here, I'm going to go backwards along in a straight line, negatively. All right, so I'm traveling in a negative direction, therefore a negative speed or negative velocity, back here to the 15 centimeter mark, or a 5 centimeter mark. So this is a minus 15. From there, my next displacement is going to be 20 centimeters east. So from there, I'm going to go back. There's 15, and then I need to go another 5 to get over here. So there, I put this underneath, is 20 centimeters. And this is where I end. So what distance did I travel? Okay, so well, distance is simply just adding up all of them. I'm taking all of them as positive values because distance is just how far did you travel. So I went 10 plus 15 plus 20 centimeters. which gives me 10, 25, 45 centimeters. So the bug actually walked 45 centimeters. But the displacement, again, straight line distance from where you start to end, then now we have to make sure we put in all those pluses and minuses. So I'm taking to the right is positive, so I'm going to put a little thing up here. So to the right is positive. So I have 10 minus 15 plus 20 centimeters. So all of that comes out to minus 5, which gives me a positive 15 centimeters from where I started. So, and this is to the right or east of where I started. So if I wanted to know then what is my, where am I in reference to 0? So in reference to 0, I missed the R, 0, my position then is 10 centimeters from where I started plus 15 centimeters to the right, which would give me 25 centimeters is my final location. You can see that because here is 0, here is 10. So my displacement from here to here is 15 centimeters, but in reference to my 0, it is that full 25 centimeters. Okay, so just be careful of what the question is asking. Is any of the problems that you're going to see down the road asking you for distance? You just add them up. If it's asking for displacement, now you have to put in the pluses and minuses in reference to some point. So having a reference point is extremely important. So in reference to the 0 position down here, the 0 position, we are at 25 centimeters. In reference to where I started, I moved a positive 15 centimeters.